What I have here, it is already a sketch of the graph of y is equal to fx. Okay, so let me explain to you how I managed to sketch this curve. Okay, first of all, it is derived of course from the function fx, okay, which is divided into two expressions. Okay, so this is a piecewise function that we are looking at. Okay, it has one expression from minus a to a and another expression from a to 2a. Let's look at this interval first. Okay, so for that interval, it is going to take up the expression of this, which is square root of 1 minus x squared over a squared. And I do not know what is a, but what I'm going to do is I'm going to just let a be some convenient real numbered values. Okay, since the question says that a is real number, I'll probably let it be equal to 1. Okay, I'm going to key that into my graphing calculator just to have a feel of the curve, okay, the shape of the curve. Okay, so if I were to press this into my calculator, okay, it is going to take up a shape that is something that is like this, okay, where the two ends here, right, they have tangents that are vertical. Okay, but of course my calculator cannot give me the values of the xy intercept. Okay, so for that I'm going to calculate it myself. Okay, so for the x-intercept, if I were to let this be equal to 0, okay, y to be equal to 0, I'll be able to get x to be plus or minus a. So this is going to be at minus a, this is going to be at a. Okay, and if I were to let x be equal to 0, y is going to be equal to 1. So at this maximum point here, okay, when x is equal to 0, y is equal to 1. Okay, and this portion of the curve, it is going to represent, this interval for fx. As for the other interval, fx is equal to 0, okay, which means that from a to 2a, okay, from a to 2a, okay, it is 2a is, let's say, here. From a to 2a, it is actually going to be this horizontal line here, and this horizontal line is y is equal to 0. Wait, that is why for my curve from minus a to 2a, the shape is this and this horizontal line. Wait, but what this question requires us is to sketch from minus 4a all the way until 6a. And to do that, I need to make use of another piece of information, which is this, that is from the question. Looking at this equation, I know what this is telling me, okay? This is the periodic function that we have discussed in our outline. For a periodic function, it is something that is like sine. For example, sine x plus 2 pi is the same as sine x, and that is what we have learned in our secondary school. Why is that so? Because 2 pi is the period. So looking at this, every time when x is added by 3a, is going to go back to fx. That is why for this function, it is going to have a period of 3a. And how do we sketch the graph of sine x? The last time, what we did is we will draw for one period, then I will duplicate this shape for every intervals of 2 pi. And that is what I've done here, because from minus a to 2a, which happened to be 3a, okay, so which happened to be one full period, I'm going to take this portion with the period of 3a, I'm going to just duplicate. That is why from 2a to 5a, it is exactly the same shape. I'm going to duplicate it towards the right and towards the left, filling everything from minus 4a to 6a, truncating anything that is beyond. Okay, that's why I have a shape that is like this. And since the question says that it can be bigger or equal to minus 4a, so I use a solid dot here, and less than or equal to 6a, so I use a solid dot here. Okay, and this is the graph of y is equal to fx.